Hey everybody, this is Larry. This is day 17 of May of the Leetcode Daily Challenge. Wow, man, time flies. What did I click on? Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and today and so forth in general. And today's problem is going to be the longest string change. So I usually solve these live, so if it's a little bit slow, fast forward or watch on 2x or whatever you need to do. So okay, given a word, you can add exactly one character word to make it longer. Okay. Longest possible length of a word chain with word chosen from a given list of words. Okay. So the key thing, one thing to note is that it doesn't have to be in order. Or sorry, it doesn't have to be starting from one character. I think it's sufficient to do it in a try, though I guess the longest answer is actually going to be 16. If you do it in a try, you can do it. I mean, yeah, we can do it. I was thinking about whether to do it statically or pre-processing or whatever, or dynamically. I guess it doesn't really matter either way. Yeah, but if you do it from a try, then that's probably okay. You just do it in order of just the fewest characters to the longest. So you do a sort, and then you just add it to the try one character at a time, and just keeping track of the longest. Yeah, I think that's basically it in concept. Yeah, I mean, then it becomes implementation details. So let's get started. So we want to sort by the length of the string, and then now for each word well, let's just have a best is equal to 0. Even technically it should be 1, but I guess it doesn't, best, and then maybe some like, I don't know, helper function that lets you add a word. And the code could be as simple as this conceptually, but of course we need to add a little bit more. And then this is basically, what do we want this to do? This adds a word to the try and return the longest length chain, right? And there are a couple of ways that people do it. I usually actually write my own try class, so let's do that. Oops. So yeah, and basically root, I just keep track of root is you go to node. And what do I do on node? So yeah, I mean, I some people do it either way, where yeah, I mean, I think this is good enough. And then I have a node class. I would also say though, I have failed on Leetcode before because it time limits, because all this abstraction is a little bit expensive. But if you're doing it for interview and you're doing it trying to get it right, I wouldn't worry about it that much. But yeah, so edges is equal to a hash table, and then we just want to know if this is the end of a word boundary. So something like n is equal to false maybe, and then we'll just do. Sometimes I write helpers, sometimes I don't, so we'll see how I feel. But yeah, but add word. So current is equal to yeah, current is equal to self.root, and then while for character in word, we basically go current is equal to what I want to do is current. How do I want to write this? I mean, you can write it in a couple of ways, but also just write like longest is equal to 0, current 1 is equal to 0. So character in word, if C is in current.edges, then if this is not in it, then current.edges is C is equal to a new node, that's fine. And then current is equal to current.edges of C. Yeah, but and then now if current dot n is equal to true, then we current 1, we increment 1, else current 1 is equal to 0, and then longest is equal to the max of the longest and the current 1. And then we just return the longest at the end. And of course at very end we also do this current dot n is equal to true, and then I think I have to do yeah, this is a little bit awkward because the last node will, unless there's a duplicate entry, the last node is always gonna, this part is always gonna be false. So, how do I check that in a good way? I mean, you guys run it twice. Maybe that's the cleanest, and it doesn't affect the complexity that much. But I'm trying to think about how to do it in an if statement that isn't too yucky. Maybe we just do it to the second last word, and then now C is equal to the last character, and then we just do current is equal to current.edges of C. Again, this is kind of awkward, but it's okay for now. And maybe you want to write helpers because now this gets a little bit messy. But yeah, and when it goes to true, current 1 increment by 1. Okay, and that's pretty much and that's pretty much it, I think. Because then now actually we don't let me shift this comment here. You probably could have changed a few things in terms of exposing edge in a more OOP friendly way, but I'm just doing this in the interest of time and laziness, to be honest. So yeah, so I think this is roughly right. Maybe there's some like silliness, but let's give it a spin. 2. That's interesting. A B B A B C A do. Let's also put in the other one, but this is actually way off. But conceptually, this is okay. If you're a regular if you're a regular watcher of the stream, you know that I make a lot of silly mistakes. I think that's what I was trying to say. So yeah, let's see. AA, BA is good. BCA is 1. That's also true. BDA is 1. That's also true. BDCA is 1. Did I misread the problem? Maybe I misread the problem. Oh, letter anywhere in the word. Okay, sorry friends. If you're watching up until now, I apparently solved the wrong problem where I just misread this, where I guess if I take a quick look, this would have been true. Now I have to think about it again, because I was thinking about the one where you only add characters to the suffix, which is why try works. Clearly, if it isn't, then this doesn't work. But it's I mean, there's a different solution. I hope you like this solution though, for the wrong question. But let's erase this. Let's see. Because basically what you would do is just a sort of dynamic programming, I guess. You still want to sort the character. You still want to sort the word by different characters. And random aside is that I've been doing this lately, and it's kind of bad. I need to read better, because I think I push myself to be a little bit too fast, and I end up not reading everything. And this happens in contests too. If you see me in contests, there are a couple of times where I end up solving 2 problems, and that's why my timing is a little bad. But yeah, but now I think we just have to, it's kind of like dynamic programming, where for every word you try to look up every word minus 1 character, and I think that should be good enough. So yeah, So let's do that. So for word in words, so let's say dp is equal to collection of default dictionary, and let's just use a regular thing. Yeah, why not? So then now for word, yeah, let's see. I'm just trying to think about a base case. I think this is pretty straightforward-ish conceptually, but now, yeah. So at the very end, we want to set this to at least. Is that true? Yeah. So we just do maybe something like best previous is equal to 0, and then 4. I mean, we're just going to iterate through the length of the word, but I'm trying to think about a clever way of doing this where, I mean, we'll worry about cleverness later, maybe. We'll just do something like word index plus word index plus 1. Is this right? Basically, what I'm trying to do is just take out one character at a time. Let's print this out real quick, because I'm really bad at this. So yeah, A B C A B A B C. Okay, so this seems like this is what I want. Could be wrong, but yeah. So basically, if n word is in DP, then best previous is equal to max of best previous DP n word. N word is for next word, though. Maybe that's not that clear, right? I have a lazy habit from competitive programming that does this. In my real code, I take the time to fix this, but yeah. Okay, so now I guess technically this is actually previous word, not next word, because we're looking for the previous. Let me fix that to be more precise. Okay, and then now at the very end, then we just said dp of word is equal to best previous. And then now we can just, return max of the dp.values, meaning, I mean, you could have also just did it in a running kind of way, but we can look for it one more time just to get the max. That's, let me just find one code button. There we go. Okay, well, that's a little bit disappointing. And that's because I need to have this +1. I forgot. That's all. Yeah, okay, so that looks good. The +1 is from adding the current word to the longest chain. So the idea here is, so what am I doing here, right? So for every word, and keeping in mind that this is sorted in increasing length, for every word, I realized that I kind of skipped ahead for the explanation. That's my bad, because I think some of that is, I was trying to solve 2 problems, and the second one, I think I was just like, let me at least try to get it right first before I embarrass myself again. But basically, for every word, we basically say, okay, how do we get to this word? Let's say we have B, I think I printed it out. Okay, maybe I don't print it out. But for every word, let's say BDCA, we go, well, this can only be a chain from the previous word, which is if the previous word is either DCA, BCA, and BDA, right? And this is just, of course, minus the B, minus the D, minus the C, and also minus the C. I forgot, minus the A. Sorry, I forgot about that. But basically, these are the previous words. And basically, what we're doing is that we, on a brute force kind of way, we look for every previous word, and then we take the best or the longest chain so far. And then at the very end, we put it back into the word of, okay, so if this word comes up in the future, we just do the best previous one +1, and of course that's going to have a base case of 0. Oh, sorry, 0 + 1, which is 1. Okay, let's actually give a submit first, just in case I have a timeout limited or something like that, but it should be okay. Yeah. So what is the complexity here? The second thing to notice, and I did notice this, but I didn't mention it, which is that the length of each word is 16, I think, and yeah, and word is 1,000, so you can kind of do the loops this way, right? And there's definitely a cleaner way to do this, because this actually makes the complexity a little bit yuckier than it. I mean, it's not so bad because each length is only 16, but you know, it accumulates, and if the word is any longer, then you have to do something smarter, perhaps some sort of rolling hash in a smarter way. But that said, so there are n words, and each one has c characters. So this is going to be O of n times c squared because of how we construct the extra word. And yeah, and even this function technically takes O of c because c is the number of characters in that word, and this as well. So this is roughly going to be right. O of n times c squared, but of course in this case, word is only 1,000 and 16 squared is what, 256, so that's way fast enough. In terms of space, oh, and actually plus n log n, sorry. For here, though, of course, if you want to be precise, because now we have characters, the sorting we compare by, well, actually we only compare by length. So I was going to say something like, you know, I mean, it depends on how you want to count the length of the character. I guess technically, because it's given to you in the form of like string helpers, technically it's O of 1, but maybe it's O of c if you want to be precise depending on your inputs. But in any case, it's roughly this. You can add a c factor if you like to be precise on how you know, implementation details of stuff that it's a little bit out of scope. But yeah, so that's running time. And then space is a little bit trickier. How many entries are there to DP? Well, there are only one for each n words, right? So that means that there's going to be O of n times c, because c is the number of characters in each word. So yeah, so that's basically all the space that we use. I'm a little bit hand wavy here because, as I said, we kind of construct a lot of extra strings here, but this one actually construct only c additional string for each n. So, you know, depending on how you want to hand wave it, but this is roughly going to be right. Like I said, you know, there are a lot of ways, a lot of dimensions to kind of think about these problems. So, so you know, you can always optimize it in another dimension. Like I said, c squared and so forth. I think that's all I have for this problem. Let me take a look at the hint, see if I missed anything. Yeah, okay, that's what I did. Yep, okay, fine. Oh, this just gives you the answer. That's nice. But yeah, you can tell that I'm solving these live because no one that is not solving a live would not solve a totally different problem to waste your time. Apologies for that. But hopefully maybe you get, you know, maybe it's a bonus, you know, you get to see Larry solve 2 problems today. Yeah. Anyway, that's all I have for today. Hit the like button, hit the subscribe button, join me in Discord. But remember to, you know, stay good, stay healthy, be, you know, help each other out, and to good mental health. I'll see you later, and have a good rest of the week. Bye bye.